Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to all. Okay, before I start my lecture for today, let me introduce myself. My name is Nurain Natasha binti Nik Muhammad Jalal with my students number 2022173863. Alright, based on the picture, what do you think that we will learn for today? First, we have the picture of fast bit of water that flow. And the second picture is we pull the syringe. Okay, for the water, when we talk about the water, it's relate to the speed. So, the speed is relate with, starting with V, which is velocity. Meanwhile, when we pull the syringe, what do you think the concept that might involve in the syringe? Starting with P. P stands for pressure. So it means the topic that we will learn for today is relationship between fluid velocity and pressure under the topic of fluid pressure and flow for Bernoulli principle. The objective for this topic is to investigate the relationship between fluid velocity and pressure. According to Bernoulli's principle theory, points with higher fluid speed in a horizontal flow of fluid will have less pressure than points with have a slower fluid of speed. To prove this principle, we can see it after this. Alright, now for the methodology. In this class session, we will use PHET simulation as our tools to help me explain the relationship between fluid velocity and the pressure. Here I provide the link which can take you directly into the website. Alright, according to the Bernoulli principle, we know that if the pressure decreases, the velocity of fluid will be increased and vice versa. Which means if the pressure increases, the velocity of fluid will be decreased. Now, as you can see in the video, which is that is a water flowing with same velocity, same pressure, and also same area, which is the speed is 12.7 meter per second and the pressure is 56.428 kilopascal. Next, the video that you can see here is flowing of the water with two different types of area, which is large area and narrow area. The larger area, which is right and left side, have same pressure, which is 135.740 kilopascal, while at the narrow area is 56.428 kilopascal. The red dot means flowing of the water. As you can see there, when the red dot enters the larger area, the red dot moves very slower compared to the narrow area. So, the pressure at the larger area is 135.740 kilopascal, while at the narrow area is 56.428 kilopascal, with the speed is 0.8 meter per second, same like as the right area. Meanwhile, for narrow area is 12.7 meter per second. So, it proves that Bernoulli principle are true. As you can see in the video, when the pressure becomes increased, the velocity of fluid will be decreased and vice versa, which is at the narrow area, when the pressure decreases, the velocity of fluid become increased. That's explain how the Bernoulli principle are work. In conclusion, this experiment effectively established the relationship between fluid velocity and pressure, proving the principle that outlined by Bernoulli. The advantages of this experiment is the information helps to further of understanding of fluid mechanics and has the potential to be used to optimize fluid-based systems for improved performance and efficiency. That's all from me. See you in the next class soon. Bye!